Hello, my dear friends. Welcome back in a new lesson. Today was Mr. Muhammad Kamal, your science teacher. Today, guys, we will start talking about electricity, and we will start talking about the lesson one, how do electric charges flow in a circuit. First, our learning objectives, we will know how electricity is transferred in a circuit. Have you ever asked yourself, what is electrical energy? Simply, my friends, electric energy is the movement of a charged particles. What are the charged particles, mister? That's what we're going to start with. First, everything around us is made of something very, very, very small called atom. The atom made of the charged particles. Here you have in front of you a diagram to show you what the atom made of. Atom made of negative particles, which we call it electrons, that moving around the nucleus. In the middle here, what the nucleus consists of? Consists of positive charged particles, which is protons, and non-charged particles, we call it neutron. The movement of the charged particles, that's what makes the electricity. We will start talking about the static electricity, which is what? Static electricity happens when positive and negative charges no longer in balance. Have you ever get an electric shock while you're opening your door? While you're touching your friend? Or touching any metal thing sometimes? That's because of what? That's because of the unbalanced charged particles. Okay? For example, while you are touching the doorknob, if the number of the positive and negative charge is unbalanced, that's cause an electric shock or cause something we give it a name, which is static electricity. The main responsible for electricity is the electrons that are revolving around the nucleus here, especially the free electrons. How do electric charges move? Electric charges move like a line. They moving as something called electric current. What is electric current? Simply, electric current is electric, a charge in motion. Electric, a charge in motion. Electric current, exactly like this picture, to start flowing from an energy source like a battery and keep moving through any resistor or any electrical device and go back again to the other pole of the battery. Let's represent our electric current here just like a line on the school. You are in the school and you are walking on line, you and your friends. What do you think will happen if the first one on the line is stopped? All the other students behind it will stop. Let's talk about what could make an electric current stop. But first, what makes the electric current to move? What materials allows the electric current to move, and what materials stop the electric current or doesn't allow it to pass through it? There are two types of material. First type called conductor, the second type is called insulator. Conductor is a material through which an electric charge can move easily. Like what? Most of the metals are conductors: iron, copper, aluminum, gold, and silver. They are all metals. They all can allow the electric current to pass through it easily. That's why the electric cords, they are made of copper or metals inside it. And it's covered with insulator. Insulator, what is insulator? Insulator is any material that doesn't allow electric current to pass through it easily, like plastic, rubber, wood, glass, cloth, cotton. They all are insulator. They all are insulators. And we covering the electric cords with insulator. Why? To prevent us from getting an electric shock. Exactly like this picture here. The conductor, and also inside this wire there's a conductor, and it covered with insulator like plastic, for example, to protect us from getting electric shock. Let's take a look about the electric circuit. Our title is what? Our lesson is how do electric charges flow in a circuit? What is circuit? Circuit is a loop where the electric current can pass through it. A loop or a way where electric current flows through it or pass through it. That's what I mean with electric circuit. There are two types of circuit, but first let's talk about what the circuit's made of. What are the components of a circuit? To build or make an electric circuit, you need four main parts. First one, you need an energy source, just like a battery or electric outlet. Second, you need wires to allow the electricity or electric current to move from the battery to the resistor. And three, you need a resistor or a device that exchange electric energy to another form of energy, like a light bulb, like a small motor, like a speaker. They all take in the electric energy and they change it to another forms of energy. And we using something called switch. Just like the light bulb, when you switch it on, switch it off, turn it off. You allow the electricity, the electric circuit, to be open or closed. Connect the components of an electric circuit in this way here. Battery, switch, electricity moving through wires. Of course, it's made of conductors. Go to the resistor, we have a light bulb here, and it back again. That's how electricity flow in a circuit. There are two types of circuit. Series circuit and parallel circuit. My friends, you can find in front of you here some symbols that we can use it to represent an electric circuit. The first symbol right here is for switch. The second symbol is for energy source. The third symbol for a resistor. We can connect it in this shape: battery, switch, resistors, and now we have an electric circuit. Electric circuits could be open, allows the electricity to pass through it, and could be closed. That electricity will move through it and go back again. Unbroken path, closed circuit, they have unbroken path. If we follow the path here, take a look, I'm gonna walk with it like this. We have no gaps and no breaks. So the closed circuit is a circuit has no gaps or breaks on it. The second type is called an open circuit. Open circuit, it has a gap or a break. Let's follow the path of the battery here. Wow, there's a cutted wire right here. By the way, electricity cannot jump from the wire and go to the light bulb. So here, the cutted wire is what is representing a gap or a break in the circuit. Any open switch, any cutted wire, any lost or missed light bulb could represent a break or a gap on an electric circuit. A circuit that has any gap or break, it's called open circuit. Let's start talking about the two types of circuit. I told you we have series circuit and the second one, parallel circuit. Let's just start in the beginning here with the series circuit. A series circuit, the current has only one path or one loop to pass through it. The The current has only one loop or one path for the electricity to flow through it. You have to know special information, advantages and disadvantages of the stereo circuits. The things are wired one right after the other. If one light bulb goes out, everything goes out. If the circuit is broken, the entire flow of the circuit will stop. What does that mean? If you take a look at this one here, you can find that it's connected one after one after one after one and so on. That's how the series circuit, it has only one way for electricity to pass through it. That simply is the series circuit. What about the parallel circuit? The parallel circuit, my friends, it has more than one path. It contains two or more branches for the current to move through it. It's called a parallel circuit. For example, we have the circuit right here. Let's follow the electric current. I have here the first loop, and I have a second loop, which is here. So I have two ways for the electricity to move through it. Other example, this one. How many passes it has? First one, the second path, and the third path or the third way for the electricity to pass through it. So this parallel circuit made of three loops. The advantages of the parallel circuit, if there is a broken or a missed light bulb, for example, the other light bulbs will keep working. Electricity keep moving on the unbroken paths. Just like this example here. Electricity, there's a broken light bulb right here. Electricity will keep moving through the other unbroken path and go back again. And also here, we have unbroken light bulb. Electricity will keep moving through the unbroken paths. And that's simply, my friends, a parallel circuit. We have two questions here. Question number 10. Classify. How can you classify materials as conductors or insulator? Question 11. Explain how a switch can affect the flow of electric current in a circuit. Expecting you guys to answer these two questions on the comments below. And now the session is not over yet. Let's go to make it practically. We are going to represent and build a series and parallel circuit and see the difference between both types of circuits. There's a virtual lab from fedcolorado.education.edu. You can use this lab to build your own series and parallel circuit. To make a circuit, you need a battery, which represents the energy source, a switch to turn on and off, and wires. And a resistor. I'm using here a light bulb as a resistor. I will use another one. Let's get a third one. Wow, Mister, we have everything here and the circuit is not working. Why? Because it's an open circuit. I have an open switch here that represent a gap on the circuit. Let's turn off the switch and figure out what's gonna happen. Electricity start to move through the loop and go to the resistor, and the light bulbs are working now. How many passes for the electric current here? You have only one loop, one way for the electricity to pass through it. So it will be what? Of course, it will be a series circuit. What is happening if we remove one light bulb in a series circuit? Let's remove this one. Can you tell me what happened? Yes, all the other light bulbs just stop working. Electricity stopped flowing in the whole loop here. Why? Because a missed light bulb make a gap on the circuit. That's one of the disadvantages of the series circuit, by the way. Let's build the second type of the circuit, which we call it parallel circuit. Battery, a switch, wires, I'm just building a simple parallel circuit for you. And you will find the link for this virtual lab on the comments, on the description. You can use PHET, PHET, or you can also use a Java lab. They are really, really helpful websites, especially in such a period, you know, the online teaching. We are not going to labs in the school as it was. I'm building for you here a parallel circuit made of 3 loops. Let's turn off the switch and figure out what's gonna happen. Wow, electricity keep working in all loops, as you can see here. Electricity has 3 passes. Here's the first pass. Here is the second one. And the third one is right here. Electricity has 3 ways, 3 loops for the electric current to move through it. Let's remove one light bulb here and check what's gonna happen. I will remove the one in the middle, for example. Wow, electricity keep working in the unbroken passes, as you can see here. And also here. So one of the advantages of the parallel circuit is that if there's a broken or a missed resistor or a light bulb, the electricity keep moving on the other loops. After knowing the difference between the series and parallel circuit, can you tell me which type of circuits we use at home to connect our old devices? Yes, I'm expecting you to answer this question in the comments below. And goodbye, my friends. That is the end of today's session. See you in the next lesson. Goodbye, everyone.